Hello and welcome back to my channel, as it were, and today we're going to be looking at central tendency and spread. And we're looking at the pros and cons of the different measures of these. So first of all, what is central tendency and what is spread? Well, central tendency is the average, and the measure of spread is effectively the different ranges of values we have. So first, measures of central tendency. We have three of these. We have the mode, which is just the average of the term that comes up the most, the data set that has the most repeats, effectively. So let's say we had a group, so 1, 1, 2, 3, 5, 5, 5, 5, 7. Then 5 would be the modal number. So, why am I writing a 7? So 5 would be our modal number. And the pros of this is it's useful for non-numerical data, and it's not usually affected by outliers. It's not usually affected by errors or omissions, because unless we have a lot of errors in this section, it won't be affected by errors because it will still be the most common value. And then it's always an observed data point. The cons of the mode are that it doesn't use all the data. So we're missing out all of this data here if we just look at the 5, which is a bit unfortunate, really. And then also there may be other values with a similar frequency. So we had the 2 1s here, but they get no mention because we had 4 5s in our group. Then the next measure of central tendency is the median. So if we have our data line here, the median would be right around here, as long as it's in the middle of all the data, or at least it's the middle term of all the data. So we have 1, 2, 3, 4, 5, 6, 7 bits of data. It would be on that term. So that's the median. The good news is it's not affected by outliers out here, and whether those are outliers is debatable, but it's not affected by outliers, and it's not significantly affected by errors, because it stays where it is, unless the median is the error, which would be problematic. And the cons of it is it doesn't make use of all the data. So, for example, this one here and this one here are ignored, but then again, what we're trying to do is find an average, so the median is still very useful. Finally, we have the mean. So when a data set is very large, a few extreme examples have very negligible effect. So let's say we had another data line, and we had a few hundred points in this region, and we had 1 point over here and 1 point over here. The average would be the mean would still be smack in the middle here, because these values represent a very small proportion of the total data set. Unfortunately, if there are fewer dots in this region, the mean will be overly affected by these two data sets. It'll be more effective if this one over here doesn't exist. I'm just going to redraw that line in, because I just made it disappear. Because that would make the mean shift that way because of this one here. And so it's problematic when we have a few extreme values when the data set is very small. Anyway, so that's our measures of central tendency: mean, mode, and median. Next we're looking at is measures of spread. So, first of all, we have the range. So the range is the distance from the smallest point to the largest point. And it's just that not distance, but that value. And then that reflects the full data set, the full range of the data set. Does what it says on the tin. And it is distorted by outliers, because let's say we had all our terms here, then the range, a more accurate range would be here, but instead we have this massive range all the way from here to here, and that doesn't reflect the whole data set, because this one here is a massive outlier. Next, what we have is the interquartile range, and the good thing about this is it's not distorted by outliers. However, it does not reflect all the data, so it will ignore the outliers. Me using the rubber again, that's very annoying. It will ignore the outliers out here, which would be not too good. And remember, the interquartile range is calculated as Q3, or the upper quartile, minus the lower quartile. Then finally we have the standard deviation, which is denoted with a sigma, or a lowercase sigma, and this is just the most common distance. So if we have our mean here, and we have our data set here, this is just the most common difference in value to the mean. So these distances, it's the sum of those distances, which is sum of x1 or xi, I equals 1 to start with, up to n, minus the mean squared, because we want the modulus value of the distance, i.e. we don't want a negative value, and if we square it we get the same value as if we squared the positive version of that number. So that's the absolute distance away, and we divide that by the number of terms, so n. And that's why we have that formula for the standard deviation. But standard deviation, when the data set is very large, a few outliers have very negligible impact. So for example, this one here has very little impact on the average of the data set. However, when the data set is very small, a few outliers can have a very huge impact. So I hope that clears things up, and I look forward to seeing you all next time.